So, okay. Let's talk some math. All right, so we are still discussing relationships between diameters, radius, and chords. And again, we just finished we are at the end of discussing the relationship between arcs and angles, inscribed angles as well as central angles. Okay, and we will be moving towards the lines outside. So today we're going to talk about tangents and how tangents and radii form angles. Okay, so we just had our agenda. We just had our community meeting. We are going to review arcs and angles again. That is in Summit. That's where we ended on Thursday. So we're going to finish that. Then we're going to talk about tangents and radii, and lastly, pull it all together in the review. So let's see how far we get. All right. So again, quick review for arcs and angles. Minor arcs are greater than 0 and less than 180 degrees. A semicircle is half of the circle, and it's 180 degrees. And major arcs are greater than 180 degrees. Every circle has a major and a minor arc between 2 points. Okay? And when you add them both together, when you add them both together, you get the complete circle, 360 degrees. And then we talked about how the measure of a central angle is related to the arc. So the arc is between H and S. So the arc is 40 degrees in the measure of the central angle. And remember, the central angle is the angle that has its vertex at the center of the circle. So the central angle is the angle from H to R to S. And you see, again, the arc is HS, and the central angle is HRS. It is the same measure as the arc, so it is 40 degrees. But then we also have an inscribed angle. And remember, an inscribed angle has its vertex on the edge of the circle. But again, it is still related to the same arc between H and S. So the inscribed angle is half the measure of the arc. So in this instance, the value of X would be 20 degrees because the arc between H and S is 40. Okay? So that is where we are. We are now going to use that information. So again, like I said, the warm-up is on Summit. So you will open a new tab. You will open it you will go to Summit. Under Summit, it's algebra 2. It's geometry. And then circles, inscribed angles. When you open inscribed angles, you will see resources. Click in the list of resources, you will see exercise set 3 or activity 3. It's called similarity returns. I think it's activity 3. I don't think it's exercise set 3, but I'm going to show you what it looks like. Here it is. No, it's not. Let me back up. Sorry about that. All right, so geometry, click circles. And then inscribed angle measures. And in inscribed angle measures, again, you should have some resources. In the resources called similarity returns. And it will look like this. Okay. So now you can type in this. You should be able to. So again, what we talked about on Thursday was in this circle, let me see if I can make it go bigger. All right, so first of all, this unit, remember, is inscribed angles. So that's the concept that we are going to use. We are going to use inscribed angles to help us determine or prove that the two triangles, CFD and EFB, are similar. And we are going to prove that they are similar by finding, good morning, by finding the measure of the three angles that make up the triangle. So, how you doing? So, we talked again on Thursday that the measures of the three angles of a triangle should total 180 degrees. So we need to tuck that information away. And we also said that, all right, in the directions, they told us that the arc from C to E is 100 degrees. And they also told us that the arc from D to B was 140 degrees. So what we left with on Thursday was you are going to name an inscribed angle or angles that are related to the arc CE. Okay, so now in this, eliminate the noise. Take out whatever lines do not relate. So now that is my question to you. Name an inscribed angle that is related to the arc from C to E. So what inscribed angle is related to this arc? That's my question. And remember, again, an inscribed angle has its vertex on the circle. And I also asked you to sketch this on your paper because this is something you might need to draw. Okay? Always draw a picture if you can. Get it in your head. Anybody got anything? Oh, I was gonna say you can put it in the chat if you don't want to say it. This is the arc. Take out any line that doesn't relate to this arc so that you can see the angle. Sometimes you got to eliminate the noise. Nobody? Okay. All right, let me pose it differently. I want you to name an angle that starts at point C, goes somewhere, and then from that somewhere, it ends up being at E. Because remember, the angle will have the 2 points that also make up the arc. So you just need to tell me what's the vertex of the angle that connects the chords. One at C, one at E. Help me. Nothing. Nobody want to take a chance, step out there. All right, I'm gonna help you with this one, but I hope that you will then be able to help me with the other one. All right, so I'm gonna stop my share because I need you to see my board. Oh, let me take roll before I go. Hey, Selima, how you doing? Morning, love. Quay, I knew you were there. Okay, I heard your voice. All right, good. All right, so let's look at this. I asked you, all right, first of all, can you all see my circle? You can see this, right? Yes, no, maybe, could be, possibly. All right, so if this is the arc, right? I said to you, eliminate the noise, take that out. So if that line wasn't there, bam, you have an angle, an inscribed angle, starting at C, going down to D, and coming up to E, right? That's one inscribed angle that's related to that arc. So again, what's the relationship between the arc, the measure of the arc, and the measure of the inscribed angle? You either got two options. It's either the same or it's a half. Which one is this? Because it is inscribed. I brought you to the water. I can't make you drink it. Is this angle going to be the same measure or half the measure of the arc? That's the question on the floor. Ladies and gentlemen, you're going to see this again on the final. Y'all better talk now. You better talk now and get it. So, again, I'm gonna walk you through this piece. All right, so this angle here is half the measure of this. So this is a 50-degree angle. So that's one angle that is attached to that arc. But we have, ouch, I'm gonna put this line back. But we have two triangles. So now on the other triangle, if again we take out the noise, we end up with an inscribed angle again that starts at C, goes over to B, and ends at E. And again, because it is an inscribed angle, that is related to this arc, regardless of what it looks like, it too is 50 degrees. So we at least now have, now I'm going to put this line back. All right, so we at least have one angle in each triangle that we know is the same measure. So now, look at the other arc, the yellow arc. So the yellow arc, excuse me. All right, I'm going to go back to the share. All right, so now the yellow arc is 140 degrees. So now what we know so far is the measure angle D is 50 degrees and the measure of angle B is 50 degrees. We just did that because they are both, again, inscribed angles related to this arc. We just had to take out this segment from C to F. We took that out so that we can see the angle is from C to D ending at E. Then when we look to the right, we took out this line to this segment between F and E. And again, we started at C, we went over to B, stopped at E. So those are the two angles that are related to this arc. So B is 50 degrees, D is 50 degrees. So with that, can we apply the knowledge? Tell me the measure of the two angles that you can find because you know the measure of this arc is 40 degrees. So again, what angle or angles are related to the arc from B to D? What you got? What two angles can you find the measure of? This only works if you talk. That's the only way this works. It's a give and take. I'm just saying. Well, can somebody at least tell me what the measure of the angle will be? If the arc is 140 degrees, what is the measure of the inscribed angle going to be? Okay. You still won't be held responsible for knowing. I suggest you make your errors now, if you're gonna make any. Again, if the arc is 140 degrees, what is going to be the measure of the angle? The inscribed angle, excuse me. well, y'all know that I'm not gonna give it to you. So we're gonna let that sit, and I'm gonna let y'all know you're gonna see this again. So, but it's all good. It's all good because it's coming back. I just want y'all to know you shall see it again, and we're gonna move on. All right. So we've talked about lines outside of a circle. I mean, inside of a circle. Now we're going outside the circle. So, given our circle P, we have 3 tangent lines. We have line F, line H, and line G. Line F hits the circle at point A. Line H hits the circle at point B. And line G hits the circle at point D. So, if you had to determine what a tangent line is, what would you say? And I know it's Monday, but let's talk about it. How would you define a tangent line? No. Nothing. Mm-hmm. All right, I'm gonna let it go for Monday.
You said what's a tangent line?
Mm-hmm.
Is a line that touch right at the point.
Yep. Thank you. I so appreciate you. Thank you. Yes, a tangent touches the circle at one point. So we have line. We have line F. Did I do? Oh, okay. Right. So line F touches at point A. Line. How about this? This thing's smart. Work smart. Hold on. Line H touches at point B. and line G touches at point D. Yep, that's a tangent. Okay, so we have, this is again our usual circle. So the tangent lines touch the circle at one point. Okay, so again, line F touches at point A. And unfortunately, I couldn't make the dot to show exactly where it would touch. The software is not capable of doing that. Again, line H, because most times the lines are named, if you remember way back in your study of geometry, lines are named with lowercase letters. So line F, line H, and line G, and again, their tangent points or their point of tangency is A, B, and D. So make sure you add that. Yeah, make sure you add that to your notes. What is a tangent line? Okay, you ready to move? Okay. So now, if we draw a radius to one of the tangents, what happens? So again, in your notes somewhere, in your notes, you draw the circle. Draw again on your tangents. If you put a dot because you are drawing it, put a dot at 0, put a dot at what would be 65, and put a dot at what would be 220. Not that they matter because we're not measuring at this point, but just so that you will have, again, you will have points where the tangent actually touches the line. So, I don't know where you would draw your tangent, but when you draw where you would draw your radius. So, I'm going to add one for you. I'm going to add where they would be or how they would look. So, again, everybody thinks in their own way. So, if you didn't, you may not have used line F. That's okay. You may have used line H. And again, that's all right. Okay, so if you had one here, and I didn't do that one right already. Move it over. Okay, I'm gonna try to get it as straight as I can. All right, so you may have gone here, and again, everybody has their own. So, do that. Change it to the same color. All right, that may have been your radius. Or if you used line H, oh gosh, that was bad. Okay. You may have chosen that one. And again, that's all right. Or you may have chosen to add your radius here. It did not move. All right, so again, it doesn't really matter which one you chose to add to draw your radii to. And what is happening at the intersection? What is happening at the point of tangency? What is being formed there? And we will see. Let me see. I'm gonna try to make this a little better. Again, I can't be anymore. Okay, that's a little better. All right, so again, what's happening here? So we have line F, and we drew a radius from P to the point A. What happened at the intersection? What is this called? Pull back on all of your old math knowledge. What's happening on the left side of this intersection as well as on the right side of the intersection? What type of angles are formed? Look at the blue radius, the radius from P to B that attached to line H. What kind of angle is this? Anybody? Go all the way back. What kind of angle looks like an L? And what is its measure? The corner of your room, the corner of a book. Yes. And what is the measure of a right angle?
90 degrees.
Talk to me. Yes. All right, so Yes. So the intersection. Yeah. So, okay. A right angle is formed when a radius is drawn to the point of D, A, N, G, E, N, C, Y. Okay, so if, and all of that means is if you draw a radius, and you know, a radius starts at the center of the circle. So if you draw a radius from the center of the circle to the point where the tangent hits the circle, you will form 90-degree angles. So here we have angle PBC, right? And angle PBC is made up of the radius from P to B, and then B is the point of tangency, the point where line H hits the circle. Okay, so I will add, oh, excuse me. All right, so oh. Angle, and you see this one with the hook means measured angle. So that's what we have. So we have a measured angle, and our angle is PBC. Oh man. And it equals 90 degrees. Okay, so again, if we had other letters out here, we will also say PD. Let's say we went to, since we're going to the right, so PDR is 90 degrees. PDL, because we went to the left, is 90 degrees. Okay, so on either side it's 90 degrees. Again, where the radius touches the point of tangency, they form right angles. And oh, excuse me. And because this angle PBC was easiest to see, that is why I used it as the example. But again, there is one angle, 190-degree angle here. There is a 90-degree angle on either side of the radius that relates to line G and the point of tangency D, as well as two 90-degree angles where the radius PA intersected with the line F at point A. So see, we also going to talk the language of math, because when you see it in writing, that's how they're going to write it. You know, they will say, name the points of tangency in this diagram. And they expect you to know that that means that point where the tangent hits the circle. So they expect you to say A, B, and D, but you have to remember the vocabulary. Okay, so again, I told you all in the beginning, I will talk the language of math. Okay. So now, I guess I've I have given you a lot. And again, ladies and gentlemen, I want you to know that that activity is not going away. You will see it again. So make sure you add this to your notes. We are coming to the end of the class. I have for attendance Fabe, Quay, Walisha, Deja, and Salima. Did anybody else come that I don't have? Okay. All right, so if you have it, then I want you to have a wonderful day. Thank you so much for coming. Know that I appreciate you, and